Good morning. This is Earth's rotation and orbit around the Sun. And today we're going to focus on Earth's rotational tilt at an axis angle of 23.5 in the month of June. My name is Dina Duguay and I am a science lab developer. In these series of labs, we're going to be looking at Earth's rotation of about 23.5, 35 degrees. These are the angle tilts of the Earth. 0 degrees, negative 23.5 degrees, and 35 degrees. And we're going to be looking specifically throughout the year. That's March, June, September, and December. At the equator, the Tropic of Cancer, the Tropic of Capricorn, and the polar circles. We're going to be looking at solar spectral irradiance, which is a measure of brightness, how bright the sun appears at that wavelength of light. And that could give us a correlation of about the heat index at that latitude. And we're going to be looking at the rotational axes at the equator, the Tropic of Cancer, the Tropic of Capricorn, and polar circles. We're also going to be looking at the angle of sunbeam inclination, which is the angle of insolation, and what happens at that angle of insolation. And this is a demo of the lesson's introduction. This particular video is basically to go over what the students need to know. They're going to be playing with the axial tilt throughout the lab, but I want to focus on 23.5 degrees. They're going to do negative 23.5, positive 23.5, 0, negative 35, and positive 35. So let's do a 23.5. To do this particular demo, set it at 23.5 because that's the tilt of the Earth, and place it at a latitude of 0. What you're going to notice is in March, the sun is directly overhead the equator. That's why it has an angle of insolation of 90 degrees. And the brightness, the majority of the heat of the Earth is on the equator at that particular time. And you can see with the sunbeams, it's directly on the equator. If you take off the sunbeams, you will not see that. Now, for the latitudes, as you go positive, and you can see this, it's in the northern hemisphere. As you go negative, you can see this, it's in the southern hemisphere. So now let's bring that up to 23. So we can see. For the latitude, it doesn't allow you to do 23.5, but you can do 23. For the 2D, you're going to see that the sun is directly overhead the equator. And if you were to change that to a higher, you're going to see that the sun is still directly over the equator because it is March. If I were to do, let's say, 23 over here, and I go to June, now the sun is directly over the northern hemisphere. And if you go to December, it's directly over the southern hemisphere. But you can also do it with the 3D, with the beams of sun, and you can play back and forth. So we've gone over the course of the year, how they manipulate the course of the year. We've gone over the axial tilt. We've gone over the latitude. We've gone over the 2D, 3D. We've gone over the sunbeam inclination, which is the insolation. We've gone over the direct horizontal irradiance. So let's go back to 0 just to go over one thing. When you want to show them that the sun is directly overhead in September, let's go. You can see it's directly over the equator. In December, it's directly overhead the southern hemisphere. And as I said, you can do this with 2D also and play around with it and have fun. So after watching the video, your students move on to the rotational axis of 23.5 at the northern latitudes, 90 north, 67 down to the equator. Then they move on to the rotational axis at 23.5 degrees angle. And one thing that I did not say, you can manipulate the axial tilt. You can manipulate the axial tilt at 23.5 degrees, at 35 degrees. You can manipulate it all throughout. Then in the particular labs, you have a steam reflection at 23.5 degrees rotational axis. And you have several other steam reflection questions. If you have any questions, you can email me at my website, which is www.edworkshops.org. And I look forward to you enjoying my videos.